let's continue our practice with derivatives. In this video, we are going to explore finding the derivative of a composite function with multiple levels of nesting and exponentiation. So to find the derivative of a composite function with exponentiation, the power rule must be applied first, followed by the chain rule. Okay, for our reference, let's first write down the formulas for the power rule and the chain rule. So if we have a function u raised to the n, then its derivative is equal to n u to the power of n minus 1 multiplied by the derivative of u, where u is the base function. So this is the power rule. And then for the composite function, if we have a composite function of f of g of x, then its derivative is equal to the derivative of the outer function, keeping the inside function the same, and then multiply the result by the derivative of the inner function g prime of x. Okay, so this is the main idea behind the chain rule. Okay, so let's apply these formulas to the given function. So y prime, now first we apply the power rule. So the exponent is 6, then the base function is cosine sine tangent to the fourth secant for x squared. So cosine sine the tangent to the fourth secant for x squared, and then we subtract 1 from the exponent, so the new exponent n minus 1 is 6 minus 1, 5. And then the next step is to multiply the result by the derivative of the base function. So the base function is this entire term here, and this is a composite function whose outer function is cosine. Now the derivative of cosine is negative sine, and then now we are applying the chain rule at this point. So the outer function is cosine, its derivative is negative sine, and then we keep the inside function the same, so sine of tangent to the fourth secant for x squared, and then we multiply the result by the derivative of the inner function. Now the inner function is sine tangent to the fourth secant for x squared. So this is a composite function, and its outer function is sine, so the derivative of sine is cosine. And then we keep the inside function the same, so the inside function is tangent to the fourth secant for x squared, and then we multiply again the result by the derivative of the inner function. Now the inner function or the inside function is tangent to the fourth secant for x squared. Now since the composite function contains exponentiation, therefore we must apply the power rule first. So the exponent is 4, and then the base function is tangent secant for x squared, and then the new exponent is 4 minus 1, which is 3, and then we multiply the result by the derivative of the base function. Now the base function is tangent secant for x squared, and this is a composite function whose outer function is tangent, so the derivative of tangent is secant squared, and then we keep the inside function the same, so that is secant for x squared, and then again we multiply the result by the derivative of the inner function, inner function now is secant for x squared, whose outer function is secant, so the derivative of secant is secant tangent. The inside function is 4x squared, and then let's multiply again the result by the inner function, which is 4x squared. The derivative of 4x squared is 8x. So it's done. The next step that we are going to do is to finalize the result. So first we multiply 8x by 4 and then 6, and then we include this negative sign. So 8x times 4 times 6 times this negative 1 here in front of this function sign, so it's negative 192x. Okay, this is done, and then we write down this term. So this is secant 4x squared tangent 4x squared, and then the next term is secant squared secant 4x squared, and then multiply by this term. So we need only to copy this tangent cube secant 4x squared, because we have already included this 4 into this negative 192x. So tangent cube secant 4x squared, and then multiplied by the next term. So cosine of tangent to the fourth secant 4x squared, and then the next term is this one. So this negative sign has been included already into this negative 192x. So what we are left with is sine of sine tangent to the fourth secant of 4x squared, and then the last term is this one. Take note that 6 has already been included into this negative 192x as well. So what we are left with is cosine to the fifth of sine tangent secant of 4x squared. So this is our final answer.